Hello, my name is John MacDonald. I'm from the School of Geographical and Earth Sciences at the University of Glasgow. In this short video, I'd like to tell you about how we can mineralize atmospheric CO2, carbon dioxide, to help us meet our net zero targets. So as a society, we need to keep global warming below 1.5 degrees Celsius. And to do that, we need to limit or even reduce our global CO2 emissions. And there's sort of two ways we can do this. There's what we might call traditional mitigation technologies. So that would be things like transitioning from fossil fuels for energy to renewable energy sources. And that can make a big contribution to reducing these CO2 emissions. Another thing we can do, though, is what we call carbon removal. So this is a small but significant contribution to make towards these global CO2 emissions reductions. And so carbon removal can take different forms. One of these is where we mineralize that CO2, either as it's being produced, so say from a factory, for example, or CO2 that's already in the atmosphere. So what do I mean by mineralizing it? Well, CO2 is, of course, a gas, but we can react that with various different materials according to this chemical reaction down to the bottom of the slide here. So we can react CO2 with materials which are rich in calcium or other similar elements like magnesium. So this could be some kinds of natural rocks. But we can also use things like slag. So that's a byproduct from an industrial process, in this case, steel making. Now, slag is a kind of rock-like product. It's grayish in color. It's quite light because it's full of holes. It's very porous. And slag is also quite a chemically reactive material. And so CO2 gas will quite happily react with slag, which is made of calcium, silicon, and oxygen. They'll quite happily react together without even any human influence on the process. And one of the products of that reaction is another mineral we call calcite. So calcium carbonate, it's got calcium, carbon, and oxygen in it. And what this new mineral represents, that is our mineralized form of our CO2 gas. So the reaction takes the calcium from the slag, combines it with the CO2 gas, and you're converting that gas into a solid form. You're mineralizing it. So this is a process that I'm interested in my research at the University of Glasgow. I use high-powered electron microscopy and chemical analysis approaches to investigate the really kind of small-scale influences and processes in this CO2 mineralization reaction. So on the left here, we can see an image from an electron microscope taken of a piece of slag, which has mineralized some of this carbon dioxide. So what we can see here is this kind of slightly speckly pale gray area with the blue label. That's our slag as it's produced from the steel making. We then got this kind of slightly darker gray, but kind of uniform gray zone here outlined with the red dashed line. This is our mineralized CO2, so this new mineral called calcite. And then in between, we've got this kind of speckly zone, which acts like a buffer, essentially, between our fresh slag and our mineralized CO2. And that is slag which has been weathered, we might say. So essentially, the calcium has been leached out, removed from the slag as part of that chemical reaction that I showed in the previous slide. It's reacted with the CO2 gas, and we've therefore precipitated this new mineral, this calcite, and that's formed on the sort of outer surface of that slag. I also use 3D analysis, so things like CT scanning. So on the right here, we can see a snapshot of a reconstructed 3D model of a piece of slag. The pink color here represents the slag itself. The green is our mineralized CO2. And I'm particularly interested in looking at these kind of small scale structures, which allow us to find out more about this chemical reaction that's happening and the processes that are influencing it. So what we can see here is that these pores, the holes, sort of circular holes in the slag, are being lined with this mineralized CO2. Some of them have got sort of blades or maybe needles of the mineralized CO2 forming in them, and some of the pores are being completely filled in with mineralized CO2. So overall, mineralizing CO2 with slag can make a contribution to net zero targets, but further research is needed to better understand this process and ultimately to try and optimize it so that we can capture as much carbon dioxide through this process as possible. If you'd like to find out more, please don't hesitate to get in touch. My email address is here, and you can also contact me on social media via these handles. Thanks very much for watching.